So let's say we have a triangle ABC, and we divided this big triangle into triangle ABD and BDC. So let's use the Pythagorean theorem in the small triangle ABD. So let's take the triangle ABD. And let's use the Pythagorean theorem. If we are using Pythagorean theorem, c square is going to be equal with the h square plus r square. And now this equation I want to solve for h, because the h is, they share both the triangles, they share in the side h. And now if I'm solving for h, so minus r this side and minus r square this side, so h square, this implies, so h square is going to be equal with the c square and minus r square. And now if I'm going to another triangle, let's say I'm going to this triangle here, BDC, and now in triangle BDC, we are going to use the same thing. We are going to use the Pythagorean theorem, and to solve this, to use here, A is the hypotenuse. So A square is going to be equal with the h square plus b minus r square. So just let me say a little bit here. A and C is a segment that is denoted with a b. And this distance here is with the r, but from D to C is b minus r. So that's why we have here b minus r square. And now again, in this one, if I wanted to solve for h, so h square is going to be equal, both sides we can subtract by minus b, with the minus b minus r square, both sides, and it turns out to be a square minus b minus r square. And now, if we are adding, or if we are equating h square with the h square, what's going to happen? So let me equate here. H square is equal to the h square. If I'm equating h square with the h square, then I'm taking the substitution. So this substitution here is c square minus r square. C square minus r square is equal to the h square. Instead of the h square, I'm substituting with the c square minus r square is equal. Now instead of this h square here, I'm taking its a substitution, which is a square minus b minus r square. And now let me distribute here inside. Let me use the binomial formula. Let me write here a c square minus r square is equal to the a square. Here is a minus. But inside here, let me take everything here. B square, here is a minus. So the sign is going to be minus. So just let me erase this here a little bit. So this is a minus 2br plus r square. But because I have here this minus, I'm going to distribute everything. Minus r square, and this is going to be equal to the a square minus b square. So I'm distributing minus inside. Negative is a positive 2br, and negative times positive is a negative r square. But now this equation, because I have minus r square both sides, so I'm going this r square to add both sides r square. And this we can simplify here. And what remains a c square is equal to the a square. That's what remains, minus b square minus plus 2br. And what I'm going here to do now, I'm going both sides to add the plus b square minus 2br. Both sides. And a b square plus b square minus 2br. So this we can cancel, and what we get? We get the a square is going to be equal with a c square plus b square minus 2br. Okay. But now I want to know what is r here. If we are looking here r, so let me take a bit different color. If I'm looking at this r here, so this angle here angle A in opposite has h over c, and this is the adjacent side. And I want now adjacent side and the c. This relationship to find out. But this relationship is related with the cosine. So the cosine of angle A is going to be equal with the adjacent, so this is the adjacent side over the hypotenuse. And adjacent side happens to be r over c. If we are multiplying everything here by c, this side and the other side, so let me put here times c here and times c here. C with the c goes away, and r is going to be equal with the c times cosine A. Okay, and now instead of this r here, I am going to substitute c cosine A. And what is going to be now the formula? Now a squared, so let me write the one a different color so that I didn't use, but I think I used all of them, but let me write this one here. So a squared is going to be equal to the c squared plus b squared, and here is a minus 2b, okay? And instead of this r here, I'm going to substitute c cosine A times c cosine A. So we already proved for one case, then a squared is equal to c squared plus b squared minus 2bc cosine A. Similarly, in the same way how we proved this for this side, the a squared is equal to c squared plus b squared minus 2bc cosine A, we can prove for all other sides, for the c squared and b squared. And because those are the same in a similar way, so it's not necessary to write it, but we just can write here somewhere. So let me write here, b squared is going to be equal to the a squared plus c squared minus 2ac cosine b. And same thing is going to be the c squared is going to be equal to the a plus b squared minus 2ab cosine c. So in the same way, we are going to derive those formula in the same way how did we derive this formula here.